Good afternoon. I'm Florian Alami from Visicon and welcome you to our webinar on 4 ways to automatically identify model changes. I'm going to keep today's session short and primarily focus on a few examples. You will have an opportunity to ask questions at the end of the session, and I am also recording today's meeting and will make a link available to you. So let's dive straight into it and ask the question, why are we meeting today to discuss a better way to identify model changes? And that's because in our project delivery process, whether we're an engineer, contractor, fabricator, it's pretty challenging to stay on top of the constantly changing models. And being able to identify or effectively identify what changes have happened, whether I've created, if I've created the model, I may want to communicate the changes. And if I'm receiving or working with other people's models, I want to be able to identify what they've changed to know how that may affect my scope or not. So what are the types of changes we're talking about? Simple things like the slab edges could have changed, slab thickness, openings, did something move, was a property changed, right? Some of these things are, everything above is geometric, but sometimes they're properties of the model that are changing underneath the components that have a significant effect, but we might not actually see those very obviously. So in other words, there's an endless possibility of the type of changes that can happen in models. And what we're going to go through is show you how Visicon can help you. So luckily, we've developed 4 algorithms that help you track and identify different types of changes in the model. Those are what I'm going to call deep data comparison, a 3D Boolean difference, a parameter-driven comparison, and lastly, a variance report. And what we're going to spend the rest of the time doing is we're going to go through a specific different project for each one of those 4 changes, and I'll kind of walk you through how to pull in the models, how to set up the comparison, and how to see the change. In each of the cases, we would have started out, and in my example, I'm using all exclusively Revit models, and actually that's not true. I do pull in some Tekla models at the end. So just to kind of set the context, what we would have done in all of these cases and examples that I'm going to go through, we would have started in a Revit model. So either you have the Revit license or somebody else has the Revit license. When you've installed Visicon, you have the Visicon plugin, and you would have gone through the export process, right? So I've kind of, to streamline today's presentation, I've pre-processed all of the various model versions for that and end up with a VXF file of each of the Revit versions, right? So that's our point of departure. So what we're going to do is the first thing we're going to dive into is a deep data comparison. So what's the purpose of it? So this is a case where you have 2 versions of a model and you have no idea what you're looking for as far as the changes go, right? So this is going to put yourself in a manager situation, and your objective is just to really do a full data audit of the models versions and check to make sure that things that you didn't expect didn't change, right? So this identifies all changes. And the way you do that is you run what's called the compare models operation. And you'll see in Visicon, the terminology we use is all of these various model comparison algorithms are called operations. So let's jump into our deep data example. As I mentioned, I've already pre-processed. I would have had 2 versions of a Revit model. In this case, where I've picked an HVAC example. What we would then do next is we would open a blank Visicon. This is the only operation where you actually start in the program and pull in the files. All of the other operations, you bring in the files first and then run the operation. So here we're going to go to operations, and you see here on the left side, it says compare models. We're going to go ahead and grab that. And what we're going to do is we're going to go to our folder where we have the 2 versions saved. We pick the first one. So we're going to compare we're going to have the program identify the changes from the first file that we select to what the condition is of the second file. So here we're picking hospital HVAC version 1. We select hospital HVAC version 2. And in the background, you can see the status bar at the bottom. It's doing its processing. It has identified a few objects with duplicate unique IDs. It can't do a proper comparison on those, so we say we ignore those, but you'll see a list of them. And the way this data is presented to you is initially in a tabular format. So here, let's look at this. So what this does, it gives you full insight into what's changed. The way the data is organized is you have three, or actually really four categories. You have objects that are only in model A. So model A would have been our version 1 model. So here we can see there was a particular view, there were some work sets, but most importantly, there are some duct fittings, right? So these were only in model A, which means these were deleted. So these were the objects that were deleted in the first model. We have also a couple ducts that were added in the second version of the model. We have 20,411 components. You see that where it says identical, where 100% of every parameter is the same, which means geometry, family, properties. And the program has identified 112 components that where something is conflicting. So then we can start drilling down. So if we open up, for example, here, these ducts, and if we click, what you can see is that there's been a small change in geometry. And that's because one of the main air supply feeders, the dimension was changed. And so a lot of the little taps and connections that were linked to it were automatically changed in size. So what you can see is this just gives you, you can browse through and it highlights exactly which parameters were changed. So let's go, and I'm going to scroll down to the bottom. Yeah, so these are all components, these duct components where the geometry changed. Then we have some fittings. So if we click on the fittings, you can see it's highlighting among its parameters. We have 29 parameters. If I expand the parameters, these are what you would consider instance or family type of parameters. And can you see here that it's highlighting that the construction phase, so this is a perfect example of where a hidden non-geometric parameter changed in your model. So it's flagging it and saying it was new construction, it has now been tagged to existing, right? So you can do that in all of these parameters. And that's exactly what's changed. So here, for example, the system, because the geometry of the system changed, also the automatically calculated pressure losses and etc. were also recalculated, and that parameter is also identified. The four components that had identical unique IDs are listed here. So in summary, this gives you an opportunity to really drill down into the model, do a quick audit, and understand what potentially has changed that you're not aware of. You can exclude certain components from this algorithm where you say, well, I don't really care, for example, if the author of the component changed. I only want to care about geometric things. So you could do that here. You can export all of this detailed information into an Excel spreadsheet, or you can import it into the main Visicon graphical interface with each of the changes identified as an issue. So here we're looking at the two merged models, right? So we have one model versus the other. I can change their colors, right? So you can see there's barely any, you can see some small changes here, but that's difficult to pick up. What we can do is under issues, it lists exactly which component. So if you want to see which object was only in model A, I go to my home auto fit, and it tells you exactly that's the fitting that was deleted in one of the models. And for example, here it shows you that this particular air feeder was rotated, and it gives you specific information on exactly which parameters were changed. You can see here each of the issues and components lists it's changed. So in summary, the deep data comparison, which you can invoke by going to the compare models, is a great auditing tool that gives you insight into potential changes in your model that are both geometric as well as non-geometric parameters, and gives you a complete overview of the changes. So let's go ahead and close that. Perfect. So now we'll go to our second example. The second example, which is one of our most popular features, is called 3D Boolean Difference. So when is this one used, right? So the previous one was just a full audit of all changes. Now you're only interested in physical 3D changes, right? And we're not satisfied with running, let's say, a BIM 360 model compare where the components that have changed are all just color coded. we want to know exactly what has changed. And so this allows you to pinpoint the exact changes. And to run this, you go to the operations and you run the Boolean difference operation. So let's go ahead and do that. I'm going to go back to the folders that I've set up. So for 3D Boolean, in this example, I'm going to pull up an architectural model. This is a scenario where I receive weekly updated architectural models, and my objective of running the 3D Boolean difference operation is to have an insight into what the architects changed. I don't always trust that they've covered everything in the narrative, or it's just time consuming to do that. So here we're going to go ahead and again, open a blank Visicon session. This time, we're going to drop the two file versions into it. So you see, I select these two, Arc version 1, Arc version 2, drop them into Visicon. We don't need to synchronize views. What Visicon has done now is it has now merged the two versions of the models. Again, just like before, we can click on the model tab, change the color of one of them, and you may be able to see some changes, but it's really not very effective, especially if you have a lot of minute changes inside the model that you might not catch. So in this case, we go to operations and we're going to go to Boolean difference. And we're going to call this just our arc changes. The way you configure it is you have we're going to do a solid volume comparison. The program, whenever there are two models only, already makes a guess and has placed the first model as the original model and the second model as our updated model. I would be able to pull down this list and change that. In the next examples, we'll go and use filters. Right now, we'll skip over those. So all we had to do here was drop in the two models, say which is our original model, which is the updated model, and then run the operation. It's doing its calculations and will shortly give us the answer. Here we go. 205 identified changes. Visicon is all about conveying information about the models using various color codings. What you'll see is that on the bottom, I've switched from model color code, where in this case we had one model is orange, one model is white, material color mode, discipline color mode, and whenever we run an operation, we end up in what's called issue color mode. So this is where the components that are affected, in this case, have a geometric change, are color coded. They're color coded based on color coding here in the operation. So green means something is new. So the architect added new mass. Orange means something was removed. So already you can see that everything that's transparent in the structure was not changed. I can immediately identify that a column was added at this corner. I zoom in closer and I can see that this roof slab was made thicker and that it was made thicker by keeping the top elevation constant and adding some thickness to the bottom. This column is hollow in the middle, which means it didn't change. It was made wider. We have green on the sides. If we look at the facade on the outside, again, we can see where the facade has changed, where some window types have been swapped out, right? Orange was the original window framing, green is the new window framing. I can simplify this even further by going to issues and only isolate my issues. So this gives you X-ray vision into the building to know exactly what's changed. So for example, if I zoom in here, how do I interpret this? This is telling me that this wall did not change in thickness. It was positioned to the right, occupying the orange space, has been nudged and moved to the left, now occupying the green space. So you can use this to very effectively identify things like slab changes, opening changes, changes in columns, all types of nuanced geometric changes. So here we're going to go to visibility and only turn on our slabs, columns, and you can see much clearer, for example, here where these stair openings have been made smaller because we have green is new concrete that's been placed there, okay? So this is a nice example of how the Boolean difference allows you to quickly drill into geometric changes that are made in any two sets of models. So let's go ahead and close that. So then the third model comparison algorithm that I want to go over with you, I'm calling parameter-driven comparison. In this case, when would you use it? When you are aware of a very particular parameter. Now, it could be geometric, It could be non-geometric, but you know there's a certain parameter in your model and you're just interested to know, has that changed anywhere? And you want the program to be able to identify that for you. In this case, we're going to run what's called a variance check operation. So let's go, and just like in previous examples, we're going to go to our variance check. In this case, I've decided to use a concrete structural Revit model. Just like before, I've gone through and pre-exported the two versions. This should start becoming repetition. We open our Visicon blank model, grab this. We're going to take the two versions of our Revit structural model. We don't worry about synchronizing views. And if we look at the model view program, again, I can assign one is white. So even if I change, right, this is one model, this is the other model, it's really hard for me to see the nuance changes in here. So what I'm going to do is I'm going to go to operations, and then this time I'm going to use my variance check operation. A variance check, and we said we're interested in only knowing if the slab thickness changed. So I'm going to say slab thickness changes. We're going to give it a color. And so how do we configure this? So first thing it says all changes, that's fine. Then we're going to say which version. Again, the program happened to correctly select the version 1 model as the starting point and the version 2 model as the second point. We can then exclude or constrain our search. In our case, because I said I'm going to show you how to constrain the search using filters, we're going to go in and go to filters. We're going to create a new filter, and we're going to call this slabs. And under the expression, we're going to select slabs. We're just going to simply use our floor systems here. We're going to select all of those. I guess we could be more specific and just limit it to structural floors. In this case, that doesn't matter. So here we have a slab filter defined. We go back to our operation. And so all we're going to do is here where it says constrain it for both the input, the original model and the final model, we're going to say limit our changes to slabs. Okay, so we're looking at all changes from model version 1 to model version 2. We're limiting it to slabs. And now the question is, well, what change do we want to see, right? The geometric one was easy. The program knows it's just looking at 3D geometry. In this example, we need to give it some more definition as far as what we're interested in. If I select any component in Visicon, I have all of its properties here. We said we're interested in knowing, did slab thickness change anywhere? So if I scroll down on any of these slab properties, can you see there's a property called thickness? I simply copy, right-click, copy that variable. And here where it says variance to show, I can put any number of those properties in here. So what we're doing now is we're going to check the all changes from version 1 model to version 2 model, slabs only, did the thickness change? It's that simple, and we're going to run it. It has found 4 changes. Just like previous times, we now are defaulted into our issue color mode. And based on the color we assigned, I can now browse through the model and I see immediately where there were changes in slab thickness. You see there's some core at the inner core there. There was another inner core slab change. And so there should be 4 total changes, and there's another change right there. I can go to the issue list, each one of these issues, and if I go to auto fit, here is that one change. It tells you exactly that that internal slab was changed from a 4.5-inch concrete on 3-inch metal deck to a 4.5-inch lightweight concrete on 2-inch composite metal deck. All right, I go to this one. This one changed from a 9-inch to 8-inch PT slab and so forth. Right, 9-inch to 10-inch, and here it went from a 12-inch to 10-inch slab. So this makes it really simple for you to be able to dial in exactly what you're after and use Visicon to hone in on those changes. The filters, the operations, all the little steps that I'm going through right now to configure each of these comparisons, don't worry. If you're the power user in your office, you simply go to Save As Template, distribute that template to everybody in your office, and then you have the next iteration. Anybody else in your office can kind of streamline the whole process by applying one of the templates that you have predefined. This concludes our example on the using a parameter to graphically display and generate this. I can generate a report also. I can go to reports. This is going to be my issue summary report. There's only one operation selected, so we're just gonna run this, and you can see, just opening up the Excel spreadsheet, it has listed every single one of those slabs where the parameter that we were interested in, slab thickness, has changed, and it gives you a summary of everything that you need, right? So it makes it very, again, you have multiple ways to look at the data of what's changed in your models. Fantastic tool as a project manager or someone who has to take in and work with models that others create. So let's go ahead and close this. So the last example that I want to show you is called a variance report. It's a little bit different. You could say, well, Florian, you just showed us an Excel report. How is this different? I like the variance report for when it comes to quantifying the changes, right? The list of issues, yes, you can print out and tell the program to give you all the parameters, but this variance report is really useful in quantifying the changes because you can specify what you're looking for and it'll give you a nice variance report that'll tell you what's been added, what's been changed, and what's been deleted, right? Fantastic tool to be able to use for change management or documenting, let's say, plus or minus concrete saving, steel saving, etc. How do you run this? This is run using the variance report. In this example, I've chosen to use a steel structure, right? So I want to give you some variety of project types. So we're going to go to our variance report. These are somewhat large models. So I've already I went one more extra step where I already merged the V1 and V2 versions of the steel plant. So we're just going to go and open that. Again, I've done absolutely no other configuration. This, as I had mentioned, this is now a Tekla model. So here we have a very detailed steel plant, just like in all previous examples. I can change the colors. It's pretty much impossible for me to see what's changed. I've been tasked with providing a report to my client on how many inches or length of weld were changed between the previous submittal and the current submittal. I'm going to switch to my material color mode. I zoom in, and what you can see is we have these weld objects, and how I characterize and understand that an object is a weld by its name, right? If this were a Revit, it would be different because it would be a weld family, but because it's coming from Tekla as IFC, it's most of the things in Tekla, unless they're beams, are just generic. So, but can you see here that it says weld? So we're going to take that name. We're going to create our first filter. So we're going to create and say welds. This time we're going to use an expression. We're going to say name equals weld. If I hit return, do you see that it's selected 58,248 objects? These are all the various welds that have been selected. I can go to isolate. These are all the welds that we're going to check, right? Could you imagine doing this manually? So there are lots and lots and lots of welds, but we made some changes, and my client wants to know, they're concerned that the weld length increased. So I'm going to go, so we've defined welds. We're going to go to reports. This time I said we're going to run the variance report. So this is going to be my weld change report. How does this work? We, again, want to see all changes. You can look at, what's been added, modified, or removed. In our case, we want to do a full audit of what's changed. The program happened to pick correctly plant version model version 1 against plant version 2. We're going to constrain, again, we don't want to check everything. We only want to check welds, right? So we're going to take advantage of that filter that I just created. And then how do we want to group it? So if I grab one of these weld objects, and if I look at the parameters, these are all the parameters that came from Tekla. I want to group by weld type, right? You see whether it's workshop or field. So I'm going to copy that variable and say group by weld site. Next, group by the weld type. I'm going to go ahead and copy that variable. So we're going to group by those two things. And we're going to, then it says variance to show. That's what's the change we're looking for. You see, if I select this, can you see that this weld has a length? So I'm going to copy that length parameter because I don't care about count. We know there are 20,000 of them. I just want to know, did the length of any of them change? For each one of them, what else do we want to see? Maybe we want to see this, object placement, or let's say there's another here, what type of, instead of name, what type of weld it is. And then we just simply run this. So again, Visicon is running through over 20,000 welds, only looking at the parameter weld length, and is going to create an Excel spreadsheet for us in a second with the results. So of the 20,000, I can now with confidence go to my client and say, yes, a lot of things moved, but the actual number of welds reduced by 80 millimeters. These are the 4 welds that changed. You can see here was the original weld length, here's the new weld length, and here's the delta. This table would expand and include things, right? If it were a deleted weld, you would see the quantity would only be in B. If it was deleted, it would only be in A. If it was added, it would be in B. And you can see the variance can either be a positive or negative. And then you just sum all this up, and it tells you exactly how much in cubic yards of concrete, tonnage of steel, in this case, length of welds. You configure the program to have it tell you exactly what has changed, and it does it so simply and fast. Again, this was over 20,000 objects. So that is an example of a large steel plant drilling down into a nuanced change of how many millimeters of weld length changed between 2 design iterations. I have been focusing on Revit files, but just want to re-emphasize that all exercises, or the 4 operations that I just showed you, work equally across Revit, ETABS, IFC, so that's Tekla, Vector Form, all of those other programs, or Adapt. Take any 2 versions of those models, run through those 4 algorithms that I just showed you, and you can find out, do a full data analysis. You can do geometric using Boolean. You can do the variance report so that you can graphically see where the changes are and run that Excel spreadsheet, or do a variance report if you're concerned about quantity changes. So in summary, Visicon, I believe, has developed the most efficient and precise way for you to be able to find and track changes in models. And I highly encourage you, if you have not yet, go out and go to our website and download a free trial. And again, thanks for participating and listening in today's session. I'm going to formally close and stop the recording.